So you know how much I like to go to the grocery store. I mean, it's fairly obvious. It's my fun time. So if you could buy 1.67 pounds of bananas for 87 cents, how many pounds could you buy for $3? Do you understand what you're setting up here? You got a couple of ways of setting this up. Now I'm going to set it up in the way that makes the most sense to me, which is typically dollars per pound. This is how I'd be setting mine up. How about you guys? Now, if you can do it this way, or you can do the pounds per dollar. It doesn't matter. It doesn't matter at all. But what does matter is that when you get to your proportion, you don't flip those guys. You keep it, if you're going to do it where dollars is the numerator, where the money is the numerator, then the other side, the numerator has to be dollars as well. You have to keep it the same. So if I want to do this, so cost per pound, so that's going to be 0.87 to 1.67 pounds. Are you with me on that? Now look what I did. This 0.87 is what? This is cost measured in dollars. And what's this denominator part? The denominator part is the weight measured in pounds. That means when I'm setting up my proportion on the right side here, I have to keep the same units and the same pieces I'm discussing here. So I have to have the cost over the weight. If I flip that, if I flip those units, your answer is wrong, so wrong. Sorry, mine is like flipping out over here. So there's one situation that you know both the numerator and denominator. It's the other part where you only know half of it. Look at the question. How many pounds of bananas? So it's asking you for that, right? So do you have that? That's what you need to find. So that tells me that I should probably put my X for the pounds of bananas, right? So maybe my X would be right here. To confirm that though, read the rest of the sentence. Could you buy with $3? So it's telling you you have $3, so it's telling me I could spend $3, and what would be the weight of bananas? How many? I can't say how many bananas, but what's the weight of bananas that I could purchase? So can you set this equation up now? This is the proportion. How do we go from this to the nice equation? Some of you are already pressing buttons on the calculator, and that kind of unnerves me a little bit. What did you do? No, you don't cross multiply my class. We don't ever cross multiply my class. No. We set the cross products equal to each other. Please don't say cross multiply. That goes for you too, YouTubers. So we have 0.87 times x is equal to the other cross product. So that's 1.67 times 3. Bless you. So if we're doing the work here, that's 0.87 x is equal to 3 times 1.67. What'd you get? 5.01. Do you guys agree with that? All right. Wait a minute. All right. So I was thinking something else. So 5.01, how do I finish this? How do I get x by itself? Divide by 0.87. So that means that x is going to equal what? Well, I got my calculator, which is a good thing, right? So 5.01 divided by 0.87. What do you guys have? So roughly, I could buy how many pounds of bananas? So this is about 5.76. So if we're going to state this in a sentence so it's easy to interpret, so we could buy, I'm going to use the word about, we could buy about 5 point, actually no, if we buy 5.76, that might go just over the $3 mark, so we might need to go down and just keep it at 5.75. We could buy about 5.75 pounds of bananas with $3. You guys agree with that? Now, here's what you could do to check this. Check to make sure that everything lines up. You're saying that 87 cents for 1.67 pounds should equal $3 for buying 5.75 pounds. Right? Is that what we're saying? So if I check the math on this, 0.87 divided by 1.67. So that's about 0.521, which would end up being, if we remember from the discussions from last week, the cost per pound, right? Unit cost. So if we do that on the other side, 3 divided by 5.75, I get something that's really close, still about 0.52, right? If you check the cross products, okay, check the cross products, is 0.87 times 5.75 equal to the same number you'd get from doing 1.67 times 3. Well, we already know this guy is 5.01 from what we did above, and 0.87 times 5.75 gives me, well, gives me about 5.00. So is that close enough to let me know that what I have is okay? It's close. It's really close. Okay. It's a lot of bananas. I'm hungry.